Where am I? If you can go answer in the comments right now and be the first, yes, you will win 5,000 math points. What are math points for? I don't know, but go and comment down below. What is in the background? Where am I? And after that, let's go and check out the measures of center. Yes, we're looking at data and how to go and calculate some things. Are you ready, Math Jedis? Here we go. Today we're looking at the measure of center. Yes, the measure of center should be quite exciting. And what we're really going to focus on though. So this is all talking about looking at basically typical values of data sets, but we're going to be focusing again on the median, mean, maybe mode, but not really. We're going to be focusing mostly on the mean and the median. We're also going to be adding something new. We're going to be talking about Outliers, which is an excellent book if you ever want to go and read that. And we're also going to be talking about something called ranges. So the range, and something really fancy called IQRs. Ooh, that sounds like it's going to be pretty cool. So those are the kinds of the words that we're going to be using as we go and talk about things. And you might want to review some of my earlier videos on mean, median, mode, and go and subscribe. That'd be awesome. And here we go. So we need to figure out how we're going to go and figure out kind of measures of center. And I want to talk about outliers. So outliers can have big impacts on the mean and the median. So it can have definitely some big impact. We're going to take a look at that. So outliers are going to be kind of the key. And for outliers, I want you guys to think of, well, I don't know, let's just think of lightsabers. So let's say we had a whole bunch of green lightsabers. So maybe you're like a Skywalker or a Yoda fan. And then maybe you're, Obi-Wan, original Anakin. You got some blue ones, you got some funky yellow ones, and you got some purple ones, right? Mace Windu, that kind of stuff. You got all these ones. And then you got this lightsaber. I'm going to use my sound effect. Right? So you got this lightsaber, and you're looking at it going like, whoa, what is that? And that was the reaction that everybody had when they saw Kylo Ren's lightsaber. And if I had to say which one is the outlier, which one doesn't belong, what doesn't belong, I think it becomes very obvious that, okay, this one, it doesn't fit. And I want you to think of that as being the outlier. It doesn't fit at all into this whole data set. These are the good guy lightsabers. This is the bad guy lightsaber. And if you know that, who uses red lightsabers, only the Sith use red lightsabers. So this one does not fit at all with Jedi lightsabers. So we're talking about outliers. We're talking about things that just don't fit. But for math, we have to have a little bit of a definition. So we just can't look at things and say, I think it's an outlier. So for math, and this will make more sense in a second, an outlier is 1.5 times the IQR, which you have no idea what I mean by that. Okay, so that's the actual math definition, 1.5 times the IQR. And let's start telling you what these things are then. So the IQR stands for the interquartile range. Interquartile, not to Lee. Let's see if I can spell this right. Interquartile range. And the keywords, what are the keywords for this one? Quart, which is kind of means quarters. And we still have that word called range. So to figure out a range, this is for any kind of range, is you subtract the big from small. The big from small. That's what a range is. That's really what it is. And this one we're talking about the interquartile range. But just for range, just so we make sure that we know what a range is, let's say you had, so here's an example. Let's say you had all this data set. So you had 3, 7, you had another 7, because that's a cool number. You had 5, you had a 2, 18, 10, and a 9. And you had to say, what's the range? So what's the range? Just what's the range in the data? Boop, 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 boop. You would just go and say, okay, what's the biggest number? What's the biggest number? There it is, 8. What's the smallest number? Oh, it's right beside it, actually. It's right beside it. It's 2. So you just go and subtract that. So 18 minus 2 and 16. So your range would be 16. That's how you go and figure out any kind of range. Now we're talking about interquartile range, and we're talking about quarters. So what do you think we need to go and do and think about? Well, let's take another example. So this is going to be the big example of the day. I'm going to give you a bunch of numbers. So here we go. So this is going to be the big example of the day, and because this is the big example of the day, we need our friend Math Bear. Yep, there's Math Bear. Here he comes. Bum, ba-dum, ba-dum, ba-dum. So Math Bear is pretty excited to be part of this example. He's like, hey, thank you. What am I doing in this example? So Math Bear, you are a hungry bear. Okay, Math Bear, you're pretty hungry, and you are eating popcorn. Ooh, I like popcorn. He says, I like popcorn. There's some popcorn. So he's going to go and eat some popcorn. And let's take a look at it. So this is going to be number of popcorns that Math Bear goes and eats. So here we go. Here's the example. So we're looking at popcorn. And here's some numbers of how many pieces that he ate. So 71, 70, 73, oops, 73, 70, 70, a little bit less, 69, 70, 72, 71, and then you got pretty hungry, 300, nom 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 nom, 71 and 69. All right, cool. So how are we gonna do this? Step 1. What are we doing here? We need to arrange. You always need a step 1. You always need to arrange your data from small to big. You see what I did there? I made small, small, and I made big, big. Haha. So that's step 1. So let's go and do that. Let's go and arrange that. I like the yellow color. So we're going to go from small. And how I like to do this is I always like to slash the numbers as I do them, so I don't make any mistakes of forgetting some of them. So I think there's like 4 70s. 3, 4. There's 4 70s. So 1, 2, 3, and 4. And I think there's 3 71s. 1, 2, 3. There's 3 71s. 1, 2, 3. There's a 72. There's a 73. And oh my gosh, Math Bear, there's a 300. Okay, so that's step 1. Step 2. I want to find the median. So remember, the median is simply the middle number. This is just the middle number. If you forgot that, you can go and watch other videos. So how do I do it? This is actually how I do it. So it's important for you to see actually how teachers actually do things. So I start going like this, so I don't make any mistakes. So I slash 1 from each end, and I just hope when I get to the end in the middle that there's like 1 number left. And oh no, there's 2 numbers left. So which one's in the middle? Well, neither of them are. You need to take the average of them. So I'm going to add them up, or maybe you can just look at this. What's the average of 70 and 71? So hopefully you know the average point would be 70.5. Okay, so that would be your median, your middle. Okay, so there you go. Now, and you know what? Let's just go and get rid of all those slashes. So this is going to look pretty. Okay, so I am going to put down this though, and just put down the 70.5 again. Okay. Well, step 3 now though. Now step 3. This is new. This is new. Is we need to find the quarters. So we need to find the quarters, the quartiles. Sweet. So we're going to do this, how you do this is you take a look at the bottom half. So here's your bottom half, right? There's your bottom half. Like that. And how many numbers are there? So you do the exact same thing that you just did for the median. So think of it this way. You want to find the median now of the bottom half. Oh, okay. So if you want to do that again, so let's use a different color. Let's use this kind of off-white cream. So again, you start doing this. Doom, 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 and uh-oh, what's the average of 70 and 70? Well, it's going to be, you guessed it, 70. So let's just do this. So the average is right here. So that would be 70. Let's go do that for the other side too. And you know, 1, 2, and then, oh, what's the average of 71 and 72? It's going to be 71.5. So it's right here, 71.5. Let me go and just draw some things now. So let's go and draw some things. I'm using these. So this will kind of show you the different quarters. It's going to kind of make boxes here. And this, you'll see where this is going in a second. So, but for us, I just want to show you that we've made 4 kind of pretty cool boxes, and those are your quartiles. Nice. So that's what we have here. So that's step 3, is find the quarters, but there's a part B to it, part B. So this is like part A. Part B is find the IQR, which stands for interquartile range. IQR is the interquartile range. And how you do it is you take your upper quartile. This is what we would call Q3. So a lot of words being thrown at you right now, but we would call this the start of kind of Q3. And this is down here. It's kind of like Q1. And I would just find the range of them. So the range. So I would go and I would go 71.5 and I would subtract 70. And then I would have 1.5 is the IQR. Bing, 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 bing. There we go. 1.5 is the IQR. Now that's pretty exciting. Why is that exciting? Because that's a really important number. The reason it's a really important number, and I'm going to get some more room here, so I'm just going to go and erase some of this. So as you're probably taking notes as a diligent student, you are probably just moving down to write this kind of stuff. So to find out if something is an outlier, right? To find out if something is the outlier, again, you take the IQR and you times it by 1.5. So the IQR was 1.5. So what you would be doing here is you'd go 1.5 times 1.5. Now that would give you a grand total of 2.25. Ooh, cool. But why is that cool, Mr. Douglas? Why? Well, now you know that if your Q3, so 71.5, plus your IQR is going to give you a total. So now we're going to get that 71.5. I'm going to add 2.25. I'm going to get this magical number of, what's that giving me? 73.75. Now this is magical because this is what it's going to say. Anything bigger than this, anything bigger is going to be an outlier. So look at our data set now. Is there anything bigger than 73.75? There is. So this is officially an outlier. It is technically an outlier. You've actually calculated if it's an outlier. That's neat. And I'll tell you why it's neat in a second. Could you go an outlier the other way though? You could. You can also go Q1 and subtract the IQR and see what happens. So you would do that 70 and I would subtract 2.25. I think that would give me what, 67.75? So if anything is lower than that, it would be an outlier. Is there anything lower than 67.75? Nope. So there's no outliers the other way as well. So do know you can have outliers top and bottom of the data sets. So now you have an outlier. Ooh. Now remember, I said that outliers can make a big impact on your calculations, especially for mean, let's say. So I want to go, and I'm going to go and calculate this data set. So I'm going to go and calculate the mean with all the data. I'm going to do that. And I'm going to calculate it without the outlier. Okay, and we're going to see what happens. So remember, mean, we're talking about the average. Which means I add up everything and then I divide by the total number of things. So how many things were there? There were 12 things, weren't there? There were 12 things. So I'm just going to go and add them up. So for this one, so remember I'm going to add up all the numbers right now. I do have my calculator out. You can't see it because, you can't see things right now, except for my writing. And listen to my voice. But I do have a calculator. I'm pushing all the buttons right now. And you want to be asking your teacher, can I use a calculator? Because really, we don't want you spending all your time trying to do all this. So you get 1,076. I'm going to divide that by 12. So if I did with all the data points, my average would be 89.6. Kind of repeating. Okay, and that's including that 300, the math bear, it was like nom nom nom, and he ate 300 pieces of popcorn. Okay, now if I don't use that outlier, there's only 11 numbers, but I'm still going to get an average. And if I do that, I divide that by 11, my average, ooh, look what happens to my average. 70 point basically 5 for repeating. Okay, so ask yourself, did that outlier have a big impact on data, on your averages? For sure. And realize that you can start manipulating data a lot. I mean, if you went and say, hey, Math Bear, on an average day, he eats almost 90 pieces of popcorn, right? Almost 90. Are you correct? Yes. But if you had said, actually, on average, Math Bear eats about 70 pieces of popcorn. Are you also correct? Yes, if you've gone and calculated things without outliers, which sometimes is the better way to do things. So manipulating data sets to serve your purpose is an important thing to kind of realize that you have the ability to do, and also to be aware that people are doing it to prove their points. So always look at data a little bit with an investigative eye to go and figure things out. So there you have it, a little talk about measures of center with and without an outlier. Hope you enjoyed. Hopefully you went and figured out where I am. But hey, I've just changed places. Where am I now? Go and comment below. And after that, check out some of my other math videos on mean, median, and mode. Maybe you'll learn some more things about data and data sets. Until next time, have a great day.